Welcome to our third module. Now we're moving on to a topic that we'll spend a few modules on due to its complexity: functional or experimental analysis. To review, why do we say that functional analyses are the only FBA method to identify a functional relation between behavior and its environmental variables? Functional analyses directly manipulate environmental variables one at a time, holding others constant, to demonstrate experimental control. This harkens back to what you learned in measurement and research methods, and in fact, a functional analysis often uses a multi-element, also known as an alternating treatments design, though it can use other experimental designs as well. Meanwhile, direct FBAs can only identify correlations between the behavior and its surrounding environmental variables. And of course, indirect assessments don't collect direct objective data on behavior in the first place. While the functional analysis methodology that you'll see most often today is based off of the work of Brian Iwata and colleagues in the 1980s and 90s, functional analysis in general has always been a part of our field. In Science and Human Behavior, published in 1953, Skinner said that the external variables of which behavior is a function provide for what may be called a causal or functional analysis. We undertake to predict and control behavior of the individual organism. That is our dependent variable. Our independent variables, the causes of behavior, are the external conditions of which behavior is a function. Relations between the two, the cause and effect relationships in behavior, are the laws of science. Let's talk about some benefits and limitations to functional analyses. Again, while direct assessments include observation of the target behavior in its natural environment, which is a good start, they only allow us to identify correlations between behavior and environmental variables, not functional relations. Functional analyses allow us to manipulate individual variables in a single subject experimental design, thus identifying functional relations between the behavior and those variables. As such, its inclusion meets the gold standard of functional behavior assessment. One common criticism of functional analyses, though, is that they're time-consuming. While it can take time to identify a clear functional relation, as we do want to wait for steady-state responding in a given condition, we'll discuss strategies to make this process as efficient as possible in coming modules. Additionally, remember that implementing a poor, ineffective intervention is more time-consuming and riskier than a thorough assessment would be. Another supposed downside to functional analyses is that they're difficult. This is absolutely true relative to indirect and direct assessment. If everything a behavior analyst did was easy, you wouldn't have to pursue this kind of intensive education. It takes training and practice in order to develop and implement good functional analyses. Another point of difficulty is the fact that functional analyses should ideally be run in relatively controlled, isolated environments. As discussed in measurement and research methods, we must be able to rule out extraneous variables. This can be less feasible if the behavior is occurring somewhere like a classroom or workplace. Again, we'll discuss some strategies for approaching and addressing this concern in coming modules. Finally, during functional analyses, we deliberately deliver consequences contingent on every instance of the target behavior. The goal is to figure out what is reinforcing that behavior. As we know, reinforcement increases the future rate of behavior. So, how can we justify doing that with a behavior we want to eliminate? This is a tricky one. Give some thought to this question, and we'll discuss it in class. As stated previously, functional analyses typically use a multi-element design. Return to your notes from measurement and research methods to review how multi-element designs are implemented. Remember that they are also called alternating treatments designs. What we want to see is differentiation in rate of responding across the conditions of the functional analysis. This allows identification of relevant contingencies of reinforcement. So, if we include a control condition and two other conditions testing for potential functions of behavior, we would want to see a steady rate of responding in one of those test conditions at a higher level than in the control condition. In this case, we see that the rate of responding is consistently higher in test condition 2 than in the control condition or test condition 1. This suggests that the variables that we are manipulating in test condition 2 are those that are functionally related to the target behavior. As mentioned previously, Iwata and colleagues initiated the regular, relatively standardized practice of functional analysis in our field in 1982. Their study was then republished with commentary in 1994. All participants in this study were children of varying ages with developmental delays who engaged in self-injurious behavior. The functional analysis included conditions of social disapproval and removal of academic demands, a condition in which participants were alone, and a control condition in which participants had non-contingent access to preferred tangible items with no demands placed upon them. We'll discuss each of these classic conditions in depth shortly. The authors used a multi-element experimental design to alternate the order of these 4 conditions. Ultimately, a function of behavior was identified for 6 of the 9 participants. For 3 participants, results were undifferentiated. Here are some results from Iwata and colleagues' study. In the case of child 1, we can see that behavior consistently occurred more often in the academic, that is, escape from demands, condition relative to all other conditions. This is a very clear case of the academic demands being aversive, and thus evoking behavior maintained by escape from those demands. In the case of child 4, we see that the behavior did occur to some degree in all conditions, but it occurred significantly more often in the alone condition. No contingent consequences are being delivered when the child is alone. This suggests that the behavior is maintained by automatic reinforcement. The behavior may be occurring less often in other conditions because there are other tasks that the child is able and encouraged to engage in. But of course, that contingent automatic reinforcement is still available. In the cases of child 2 and child 5, the results are undifferentiated and inconsistent. There are many possible interpretations of these data. Perhaps the behavior is automatically reinforced to such a degree that it will occur even when there are other tasks to engage in. Perhaps the behavior is multiply maintained by several different consequences. Perhaps there's another variable maintaining behavior that we haven't yet identified and isolated. Because of these different possibilities, we can't safely interpret these data as is. We'll talk about more in-depth functional analyses to address situations like this in future modules. Now let's talk about the typical conditions of a functional analysis as popularized by Iwata and colleagues. Note that while these are common, functional analysis conditions should always be tweaked to be individualized to each client. In the escape from demands condition, you should present a demand continually and use whatever prompting procedure is used in the natural environment if the demanded behavior does not occur. Note that the demands should be those that you see given in the natural environment, particularly if you found via an indirect and direct assessment that the target behavior tends to occur following those demands. If the demanded behavior does occur, you should not react. When the target behavior occurs, you should remove all aspects of the demand, as well as all social interaction. In the attention condition, you divert all attention from the individual. When the behavior occurs, you deliver contingent attention for a set period of time. Again, the form of that attention should be based on attention you found to follow the behavior in the natural environment based on indirect and direct assessment. The alone or ignore condition tests for the function of automatic reinforcement. As such, you want to be sure to deliver no social consequences at all. The individual should be alone in a room, or someone can be present with them if they're sure not to attend to the individual or encourage them at all. If the behavior occurs, no social consequences should be delivered. That is, there should be no reaction whatsoever. The play condition is the control condition of a functional analysis. You'll want to try to eliminate anything that could be evoking, occasioning, or reinforcing the behavior. As such, you should ensure that no possible demands are delivered, and that, essentially, the individual has non-contingent access to everything they could want. If the behavior does still occur, no social consequences should be delivered. So, ask yourself, how does a given condition test for a given function? What 2 variables are manipulated in each condition, and how do the procedures control for extraneous variables? The antecedents and consequences related to each hypothesized function are manipulated in each condition, while all other variables are either eliminated or held constant. An important review question: what's the purpose of the play condition? It is a control condition in which we want to try to prevent the behavior from occurring in the first place. We then compare the rates of the behavior in the test conditions to those in the control condition. When conducting any form of functional behavior assessment, be sure to identify and operationally define your target behavior, and in most cases, do not attempt to assess multiple topographies at a time. There's no way of knowing yet whether the multiple topographies are all in the same response class or share the same function. If they serve different functions, your results will be undifferentiated. Another guideline is to include different discriminative stimuli in each condition. You may recall this as a tip for the use of the multi-element experimental design in general. It helps behavior come under the control of the different conditions more quickly, thus leading to more immediately differentiated results. Common practices include the experimenter or clinician wearing a different colored shirt in each condition, or putting a different colored tablecloth on the table. Here's another point to consider. Should you use an ignore condition or an alone condition? And what exactly is the difference? Both conditions would test for a function of automatic reinforcement. Think about why you might choose one over the other, and we'll discuss it in class. This point will be emphasized and re-emphasized because it's so important. As great as functional analyses are at identifying the function of behavior, they can't be run without indirect and direct assessments first. We don't want to test every possible variable in the world that could be affecting an individual's behavior. We should base our test conditions on what actually appears to be happening in their natural environment. So, we should be on the lookout for idiosyncratic establishing operations. Perhaps behavior appears to be evoked by loud music, or being asked to get on the bus. Maybe attention isn't a reinforcer and instead is aversive, such that it evokes behavior maintained by escaping from attention. If attention does appear to be a reinforcer, what type of attention? Positive, punitive, vocal, physical, delivered by mom, dad, a teacher, a peer? If demands are evoking behavior, what kind? Ones that the individual doesn't know how to complete? Ones that the individual doesn't have a choice about? Math, reading, only at certain times of day? During the control condition, you won't want to include simply an arbitrary selection of toys and games. Include stimuli that you notice never seem to evoke or occasion the behavior in the natural environment. Feel out how often people interacting with the individual speak to or play with that individual when the behavior isn't occurring. That's the schedule at which you should deliver the non-contention attention. How often does the behavior occur? Note that since you actually need to record the behavior occurring during the functional analysis, sessions need to be long enough to accommodate that. At the same time, if the behavior occurs 30 times per minute, sessions don't need to be exceedingly long. Research has indicated that 5-minute sessions can be sufficient in those cases. Finally, how long should you deliver the contingent consequences during test conditions? Again, this should be based on how you see those consequences happening in the natural environment. Just be sure that you're consistent across sessions. As you can see, a functional analysis isn't a single method that you can implement out of a cookbook. It's a complex process of identifying the function of behavior, just like an experiment. We will continue to discuss how to customize this process to your individual client's needs in the next 2 modules.